We're about 2,000 meters up here on top of Kitt Peak. Down on the desert, the sun is already set. It's real windy up here, but you have to come to the tops of mountains in the thin air where you're above a lot of the cloud layers in order to clearly catch the stars. It's not far away stars we're going for tonight. It's close by big chunks of rock. To have any chance of dodging the next big cosmic bullet, you gotta see it coming. And that's exactly what astronomer Joe Montani is trying to do. He starts each night by chilling down the modern CCD detector mounted at the focus of Spacewatch's elderly but still magnificent telescope. Then Joe manually points to its first rough position on the sky. But for the rest of the night, the great old glass will be under the precise control of tiny new silicon computer chips.
And this is where it gets interesting. We can enter some coordinates of our first object of the night. Okay, this is what it comes down to. The Spacewatch observer just watches what comes in, and you must actually watch the screen. It's a little bit like driving, you don't really want to fall asleep, and you really can't. You better not. So what Spacewatch produces is an accurate list each night of positions of objects and their brightnesses. From the brightness, we can determine the size of the object. And that's important. We'd like to know if the object is 10 meters in diameter or 10 kilometers. If it's only 10 meters, maybe we don't have to do anything about it. But if it's 10 kilometers and gets anywhere near the Earth or seems to be on a threatening orbit that could intersect the Earth and maybe collide sometime soon, well, then that object will have to be somehow in the future deflected, push it away.
Of course, it helps to know what you're trying to stop. See, the old school view held that comets and asteroids were different things. If you saw a so-called hairy star growing a tail as it approached the sun, that was a comet. But if you found a chunk of rock, too small to be a planet but otherwise acting like one, well, that was an asteroid. Turns out, the difference between comet and asteroid? Maybe not so much.
We have comets that have turned into asteroids. We have comets that are on asteroid-like orbits. We have asteroids that are on comet-like orbits. And so we have a spectrum, really, of icy planetesimals, which are the comets, excometary objects that have lost their ability to outgas. And so these are the fragile asteroids. We have asteroids that have run into each other, creating silicate rocks, fractured rocks, rubble piles, and all the way to solid slabs of iron.
So it's really a range, a continuum. Like material through a mill or a factory, objects that have been processed a bit tend to be asteroidal. But chunks of raw substances left over from the very earliest days of the solar system seem to be more cometary. To find new ones, the big glass atop Kitt Peak pans across wide swaths of the sky, then repeats the same scan later that night. Compare the two scans and look for anything that moves.
So we really have two modes of working: scanning, where we're looking for new objects, and what we call follow-up, which is a special scan, a very short scan devoted to just one object, seeing how it has moved in the last little while.
Working this way, Spacewatch can truly keep watch on a whole lot of space.
So our whole field of view, well, this is only one half of it at a time, because the monitor is smaller than the number of pixels on our chip. The full chip at this scale would be, about arm's length. So a good-sized fish.
But will we catch what we're after?
I think so.